is an algebra calculation, then you can do it. So now we go to another important part is how you're going to converting or modeling particles into a wave. In which case, the section 28.5 will teach you that. 28.5 is talking about the wave property of particle. 28.5. There's a wave properties of particle. So this is a wave. Have the characteristic of lambda, frequency, and speed. In these cases, how does the particle behave? So particle has have a mass, has a velocity. Okay, so the people like De Broglie and all those people, they said if this is a particle, it can behave as a wave. In which cases they say the wavelength of this particle depends on momentum, h divided by p. In which cases p is equal to mass times velocity. So using the momentum to carry on to calculating the wavelength. Now, when you have that kind of assumption, you have to prove it. So they do a couple of different experiments. Number one experiment they done is the Davidson and German experiment, and they all prove that. And then we like you to look at example 28.5 and then 28.6 about this. So in order to observing all this activity or experiment, you need electronic microscope. So to do it. So the whole chapter, we will only cover up to 28.5. The other portion that we like to go over is uncertainty principle. The Huygens proposed that Heisenberg's uncertainty principle. So the section 28.8, the uncertainty principle. The uncertainty principle. Uncertainty principle is related with measurement. That means as soon as you try to do the measurement, the accuracy is different. He says fundamentally impossible to make a simultaneous measurement of particles' position and momentum with the infinite accuracy. So whatever you do, just measure the position and momentum. You want the terrific accuracy right on. For example, a meter stick is 100 centimeters. You write on 100 centimeters. It's very difficult. So in manufacturing, we have a tolerance. So when you're making something, you have a plus minus. So when your percentage error, again, is a plus minus. So both plus, it means larger than the standard value. Minus is smaller than standard value. So the uncertainty principle is impossible to make simultaneously measurement of a particle's position. Position and momentum. Momentum is related with velocity with infinite accuracy. So in that cases, that means delta x, delta px. Delta x is position, delta px is momentum, is larger than or smaller than h bar divided by 2. And this uncertain principle you keep talking about, then the example is 28.8. Now, in the last few important things, and I don't expecting you to study on it, but just remember the last segment of it, important part, is the name of the Schulten equation. It's a modern physics. A lot of PhD theoreticians is always trying to go back to solve Schulten equations. The Schulten equation is a differential equation. So the whole chapter of 28 we should cover up to here. So chapter 28 has no homework. Okay, only examples. So we only ask you pick the problem from the examples. So the problem I assigned you before, don't have to worry about. Chapter 28 have no homework. No homework.